Hello everyone. In this video, we are going to see the Ohm's law. Okay, the Ohm's law is a very important law that need to be understandable in a clear way because so this plays a vital role in analyzing the electrical circuits. Right. So let me get into the Ohm's law. Okay, and the definition of Ohm's law is like the potential difference across an ideal conductor is proportional to the current flowing through it. The constant of the proportionality is called as resistance R. Okay, this is a basic definition, and the Ohm's law can be also stated in a different form of definition. The current flowing in a line is directly proportional to the voltage. I mean, the potential difference across two ends, that is called as a voltage, and the inversely proportional to the resistance of the circuit. Okay, I'll repeat. The current flowing in a line is directly proportional to the voltage and indirectly proportional to the resistance of the conductor. Okay, so when the voltage or is increased, the current is increased proportionally, but when the resistance is increased, the current will go decrease. So that is what the relation between the voltage and current. Okay, see, I'm just showing the mouse pointer here. I is equal to, okay, I is equal to V by R. So I directly proportional, and it's called as V, and inversely proportional to the resistance R. Okay, but we can reframe the equation in different forms, like we can equate V is equal to I into R, and R is equal to V by I. So with this three relation, we can determine the current, we can determine the voltage, we can determine the resistance also. Because if two are known, one is unknown, we can identify in this method. Okay, and let us see a simple circuit and the finding of electrical parameters with the help of Ohm's law. Okay, so this is the first circuit, simple circuit. Let us understand there is a 20 voltage battery which supplies current to the 4 ohm resistance as a load. Okay, here voltage is known, resistance is known. Voltage is 20 and resistance is 4 ohm. So here we can apply the Ohm's law formula. I is equal to V by R, so that voltage is 20 divided by R is 4. So when we do that, we will get a 5 amp. Okay, let us consider the second circuit. The voltage is unknown, but we know what is the current, that is 1 amp, and the resistance is 12 ohm. So in this formula, we have to find the V, okay, voltage. So I'm just rewriting V is equal to IR. The current value is 1 and the resistance value is 2. So totally when we multiply, we will get 12 volt. Okay. The third circuit, the voltage is known, current is known, but the resistance is unknown. Okay. So I'm just using the same Ohm's law formula, I is equal to V by R, and I'm reframing that R is equal to V by I. So resistance here, sorry, R is equal to V by I. The voltage is 6 and the current flowing through the line is 3. So when we divide it, we will get a 2 ohms. So these are the basic relations that we could apply with the Ohm's law, and we can determine the things, right? So this is a simple assessment that you can try out by your own, and you can calculate the resistance because all these terms are related to the resistance. You can try out a little bit by your own after this, after watching the session. And in case of challenges, please let us know in the chat box so that we will try to solve and give the right. So there is a linear proportion between the voltage and current. As I said, the current is directly proportional to the voltage, or in other terms, voltage is directly proportional to the current. So this relation will be linear only at the time of constant temperature. Okay, the temperature has to be kept constant so that when I increase the voltage, the current will also increase proportionally. But in case of if no constant temperature, then these variations will happen. And also this will be suitable to the theoretical cases, where in the practical cases this may be variable one. Okay, so that is what this slide is actually telling you. And the power dissipation, it's generally power dissipation, power is nothing but the product of voltage and current. Okay, the product of voltage and current. And the power also can be expressed in different forms. Power P is equal to I square R, that is generally called as a copper loss or heat loss. And also power is equal to V square by R, and power is also termed as V into I. These three relations we can use for the power dissipation in the resistance. And that can be also solved it. And the second one is an assessment tool for hands-on experience. Okay, here current is mentioned, the resistance is mentioned, and we have to find out the voltage. Also, you can use the relations of power to determine the power dissipated in the line, which we could take it forward. Okay, so I missed out the powers here, but where after finding the voltage, you can use the power formula which is applicable to you, either I square R or V square by R or V into I. So these three things can be applied, and the power dissipation in the line can be calculated with this thing. So this is generally how the Ohm's law can be applied into the circuit to determine it. Okay, and the Ohm's law, it have certain limitations. Okay, the Ohm's law is applicable only to the DC circuits. That is one major thing. And the second is like it cannot be applied to the unilateral networks. And the third one is Ohm's law is also not applicable for non-linear elements. Okay, so that is why I said it is applicable only for the DC circuits. Okay, so we have to be cautious once we apply the Ohm's law, because here we don't have instruments like multimeter, ammeter, voltmeter. We're just going to apply the mathematical things via Ohm's law. And based on the Ohm's law, we are just applying and determining the electrical parameters like current, voltage, resistance, and also power can be determined. You can refer these references to know more about Ohm's law. Thank you.